Good day, everyone, and welcome to another Lanfrica Talk series. I am Chris Emizwe, and I'll be hosting this talk. Today, we are very excited to have Dr. Salomon. He's a doctoral candidate in computer science at Leibniz University, Hanover, and a research assistant at the AI Future Lab of the L3S Research Center and the Data Science and Digital Libraries Research Group at TIP. He has extensive research interests in natural language processing, automatic speech translation, especially for low resource languages, automatic speech recognition, machine translation, knowledge graphs, and graph in deep learning. His academic background includes a master's in mathematics science from the University of Western Cape in South Africa, and another master's from the African Master in Machine Intelligence, AMI, sponsored by Google and Facebook through the African Institute for Mathematical Sciences. We're very, very glad to have you today, and we're very, very looking forward to what you have to share with us today. Please, the floor is yours.
Perfect. Yeah. Thanks, Grace, and thanks everyone for attending this meeting. And it's a pleasure to be invited and to talk about some of our work back when I was doing my master degree in MMI, the African Master of Machine Intelligence. So let me put the slide on. Great. So the title of this presentation will be LiSTra, which is an abbreviation of Lingala Speech Translation. So this study was a case study of doing speech translation from English to Lingala. So during this talk, I will a little bit introduce that notion of what is speech translation, why did we get into this research, and how can you also do this for maybe target other language, maybe Kiswahili or any other language that you're interested to do this similar task. But before that, let me tell you a little bit more about me. So my name is Salomon Kabongo. I'm originally from this country in the middle, the Democratic Republic of Congo. Sometimes when I tell to people that I'm from Congo, they confuse it with the other Congo, which is called Congo Brazzaville. But I'm from the Democratic Republic of Congo, which is a close country to Congo Brazzaville. And I've been actually studying mathematics and computer science from University of Lubumbashi. And the language of study over there is French. Like most people coming from the DRC, most likely we do our curriculum is mostly French because we are a French-speaking country. And I put a couple of math here just to tell you a little bit my journey and how did I get into AI and how what motivated this research basically. And as you know, as a French speaker, I was interested into doing a master degree in software development initially, because when I finished math and computer science, I was saying that, okay, what next? I'm in Congo right now. What is the solution that I can bring to the community? What can I do with all this mathematics knowledge that I've got throughout my curriculum? So I was kind of disconnected because I knew how to compute a lot of complicated equations and solve mathematical system and so on, but I didn't know how those things translate in real life. So that's where I said that, okay, I need to go for a master degree. Probably it will be clear. And I first moved into Kenya on this right side, where I went to basically just learn English. So the English that you can hear me speaking started I think a few years ago when I moved to Kenya to learn English and to be able, because I knew that I wanted to do a master degree in an English-speaking country. And it was not easy. So I spent a couple of months just studying English. And before I get an admission, I was fortunate to get a full scholarship by the African Master of Machine Intelligence, but that is the second master. The first master was the African Institute for Mathematical Science. It is called AIMS in South Africa. So this is where I went to do my first master degree in mathematical science. And there it was also in English. And this is the picture on the left corner here down, where I did my master degree. And after that, I started getting interested into data science, because now I could understand what is how can I translate my mathematical knowledge in a practical things like doing machine translation, and then I get into liking more and more of AI and seeing how I can apply my knowledge in mathematics into something that people can use and something that can improve the society. And this is around the time Google and Facebook put money together to sponsor the AIMS program to build this first program of machine intelligence in the African continent. And I was lucky to be on the second cohort in Ghana, where I did the African Master of Machine Intelligence. So there, I was basically just doing ML. So from the foundation to machine learning given by Mustafa Sise and up to all the advanced topic, computer vision, natural language processing, and so on. And from there, then I start seeing the gap. Like if you are a French-speaking person, as you know, Africa is almost half of people in Africa speaks French as the education language. And it was seem I was kind of feeling that this was unfair to a lot of people. Some of you may know a lot of conferences in the African continent where most of the time it's only in English. So you are asking yourself, what about people in the African continent that don't know English at all? And I like one talk that we had at the Indaba where Vukosi said that for some people in the West or the other African language, they decide actually to learn a second language. So you have to make a choice that I have to learn a second language. But for some people in the African continent and the other part of the world, this is a must. So this is something that is made by design. You like it or not, you have to learn another language to get access to some other material or get knowledge in different area. So that basically motivated me to go into this study that I'm going to present to you. I asked myself, like, if someone doesn't know English at all, how can that person get into AI? How can he basically just know about natural language processing? For someone maybe from Kenya, Nigeria, you just go to YouTube, type natural language processing, you have a bunch of videos. But for Francophone, it's not obvious. Sometimes there is none to just few videos where you can get this concept. So I thought of, let me just do speech-to-speech translation, which was kind of crazy back then because I didn't know how can you, as I'm speaking now in English, how can you have another voice behind the scene that is speaking basically in Lingala or at least in French? So I attempted that and that didn't work out. So I say, okay, what about just doing speech to text? So basically someone speaking in English, I want at least to be able to read the text in my mother tongues. So this is basically what motivated this study. So before I go to the proper presentation, after Ghana, I went then to Germany. So this is where I'm still there in Hanover, where I'm doing my PhD at the University of Hanover. But currently I'm residing in the US. Okay, so let's go into the agenda of today. So I will talk about the introduction of this work. I did a little bit of that already, as you can guess. I will talk about the data set we constructed. And I will then go into the experimentation setup because we work with two experimentation setup. We had a cascade system that I will explain, basically some kind of two systems, separated system that came together to achieve a common task. And I will also discuss the second experimentation setup that is called an end-to-end system, like where everything is together in one box, and basically we backpropagate directly to achieve a common task as well. And I will show you the result that we obtained throughout this study, and then I will conclude and give some tips and advice and suggestion on how you can do the same thing in a language of your choice. And okay, so let's get into the introduction. So first, let me define what is automatic speech translation. I will attempt to define it by some word, as you can see in the screen, but I will also show a working prototype by Google AI, where you see someone speaking in English, and you will see directly, live translation in Lingala. So and I just recorded that from YouTube, and you can see how this system can be used in a practical setup. But basically, automatic speech translation is the task of converting a speech from a source language to transcription in a target language. So there is two flow here. You have someone speaking, and the response that we're expecting from this system is having a text that we call transcription in a language of interest. In this case of this project, we work on Lingala, which is one of the languages spoken in Congo and some other neighbor country to Congo. And the next thing, one of the biggest bottleneck with doing any machine learning for low resources language, by low resources, I mean language with less data available. And one bottleneck is the lack of data itself. And in this specific setup, the way we structure the task is the lack of aligned data, because we are using a class of learning concept that is called supervised learning. In supervised learning, basically, you have to teach the machine in a certain structure way. It's kind of teacher-student setup where you give A to a student and you tell him that this is A. So basically, you need some kind of alignment. You need some kind of structure so that the machine can learn. And in this case, we don't have two alignments. Basically, we have three alignments. The first alignment is the speech. The second one is the transcription of that script, that speech. So basically, if someone have an audio in English, you have to have the right written version of that audio in English as a second signal. And the third one is the translation of that audio in a Lingala. So basically, we have those three things aligned together. And for this work, we introduce the first data set and of reading Bible and transcription in English, as well as the translation in Lingala for the first time for the Lingala community. And the code base is there, as you can see in the link. So basically, you can go to that link afterward to just look at the data set. And one thing I should say here is that we didn't release the data set fully because of the license, but we put the script that can allow you to basically reproduce what we did and have that data set for yourself. Okay, so the traditional approach when someone is interested in doing automatic speech translation is basically first step is doing automatic speech recognition, and then take the output of that that process and do machine translation over it. So basically, that is the pipeline approach that I talked about previously. So you kind of split the task into two tasks. The first part of the task is basically doing first automatic speech recognition. So just recognizing.
Sorry to interrupt. The share thing went off. I think it's a technical issue. Could you please reshare your screen again? So sorry about that.
Sure, it's fine. Let me share again.
Thank you.
Perfect. Okay, so I was talking about the traditional approach, where the way people often do when they want to achieve this task of automatic speech translation is splitting it in two parts. Doing first automatic speech recognition, which is just recognizing what you say and putting it into text, and then getting the output of that first task and doing machine translation on it. Basically, taking that output, giving it to a machine translation model, for example, and getting the translation of that text. So basically, if you look at these two tasks, this is what is called automatic speech translation, basically on the pipeline approach. But there is the other approach, which is the end-to-end approach that we will show also in this setup, where you don't have to go through two different tasks. You combine everything in one task. But if you think about it, one biggest challenge with doing pipeline approach is that you have propagation of error. On the first task, the machine is still doing some kind of approximation on the task. So there are some error that can happen during the process. And on the second task, likewise, there is still some error. So basically, when you look at the global task, you will see that there will be the global error of the system will be some kind of a summation from the error of the first system plus the error of the second system. This is what is called the propagation of error, which is different from backpropagation, but basically that's something that you need to keep in mind when you do a pipeline approach. Okay, so let me show you a sample of this. I'm not sure if you can hear the sound. I think I need to share back with the possibility of hearing the sound. And please let me know if you can hear the sound when I play the video. Basically, this is a small demo that I put together, just showing you how you can do automatic speech translation in Lingala. So it will take just a couple of seconds, maybe 55 seconds. It's a good concept anyway. You can hear it in English. But for people that are familiar to Lingala, just look at the text, and on the Q&A, you can tell me how good you feel the text was. Okay.
I'm Jabril, and welcome to Crash Course AI. Language is one of the most impressive things humans do. It's how I'm transferring knowledge from my brain to yours right this second. Languages come in many shapes and sizes. They can be spoken or written and are made up of different components like sentences, words, letters, and characters that vary across cultures. For instance, English has 26 letters, and Chinese has tens of thousands of characters. So far, a lot of the problems we've been solving with AI and machine learning technologies have involved processing images. But the most common way that most of us interact with computers, though, is through language. We type questions into search engines, we talk to our smartphones to set alarms, and sometimes we even get a little help with our Spanish homework from Google Translate. So today, we're going to explore the field of natural language processing. I'm
Great.
Jabril, and welcome to Crash.
So as you could see from this video, I know that many of you are not familiar with Lingala, but basically this was done automatically. So there were no one sitting around and listening to the speech in English and writing the text in Lingala. So basically the system could automatically listen to the audio and write it automatically in Lingala. And think about it, what can be the advantage of this? For example, in the education sector, this is obvious. Someone who was listening to this can get an understanding of what natural language processing is from Lingala. So it doesn't have to learn French. It doesn't have to learn English in order to, to be able to get knowledge. And this can be extended for a lot of area. It may be in conferences. When you come to a big conference, you don't speak the language of the conference at all, but you can have headset, or you can have just some Googles that can allow you to see live captioning of whatever they are saying in the conference in your mother tongue. So there's a lot of application in this, but let me now get into the detail, and please forgive me if I get a little bit too technical, but I will not get too much in detail. If you're interested in more detail, we can chat after this call, but I will just give a good overview of how did we go about building this system from the beginning up to the end of this process. But before that, how does our data set look like? First, our data set is, as I said previously, a triple. So we have three entities together. The first one is the speech itself. The second one is the transcription of that script in text form. And the third one is the translation of that script in Lingala. So let me show you maybe in a tabular form that may be easier. So you have a speech, maybe in this case, as I said, this data set is made of the Bible. We have Bible, 21 verse, and so on. And that speech, basically, the content of it says, for it is better to suffer for doing good. For example, this is one sample in our data set. And the translation in Lingala say, Poeleki malamu konyo kamapo ponabozali. Quelque chose comme ça, something like that. It translated. And you will see that, as I said, we are in a supervised setting. So we have couple of hundred of text like that aligned from audio, transcription, and translation. So this is basically how our data set looks like. But one quick question that someone will have is, okay, Solomon, you said that you got the Bible and you are doing this experiment with the Bible. And for someone who has done this work before, you will realize that the Bible is often, the speech of the Bible is often by chapters. So we'll not see someone saying this is Genesis chapter 1, verse 1, and say it and stop there. So basically, Genesis chapter 1 is that talking through the chapter 1 verse. So one big challenge now was, how can we split the whole chapter in verse? Because, the length of the text is also important when you do this kind of experiment. And for all the websites we went to look at, there were an issue of cutting the text so that it can align with the speech. So this is the second part of what we did, some kind of pre-processing on the data set to obtain the format that we wanted. So we used the service that is called WebMouse Basic. And I will put the reference to that in the next slide. So basically, this a service developed somewhere in a lab in Germany, which basically, when you give it the text and the speech, it is trying to align the text and the speech automatically. So we used it to be able to basically break the reading of the Bible by chapter to split it by verse. So basically, everything that is verse 1 will only contain speech that read verse 1 until the end of the book. And the script and the code base to do that can be found in these links here, where you have the notebooks. I released it also for the community. And after all, the statistic of the data is as follow. You can see on the table. So for the English classes, we had around 23,000 examples of on the training set, and the average text length was what, 24 tokens, so which is basically a good size. And you can see also for Lingala the number are almost the same. And for the speech part, we had around also 61 hours of speech on the training sample, as you can see on this part, and we had 15 hours for testing, so which is not huge, but that was a good start. And you can, as you can see when we will show the result, it gives quite a good result next. Okay, so let's now go deep into the experiment. How did we basically set up the experiment? First, I will start with the pipeline approach, so the cascade approach that I talk about, like speech recognition, machine translation later. So what we used is we used a pre-trained model, which is called a Cirelo model. If you tap Cirelo model on Google, you basically go to a GitHub repository that will show you how can you use this pre-trained model to basically just give it a speech, and it is giving you as a black box, as to say, a text that is aligning to that speech. So because we wanted to do pipeline approach, and English is a well-documented language, we didn't find the need to actually retrain our own model for English speech recognition. So we use a serial model to just leverage the ability to get a transcript or a text form for any speech in English, which was quite interesting because we didn't have to use any compute for that. And for the latter part, then after getting that things in English, how do we go to Lingala? Then we use the traditional, we just use one of the notebook from the Masakani community to just have a model that is able to take speech, text in English and receive a translation in Lingala. And the architecture of this look like this. So for the serial model, you don't have to understand this, but basically how the setup was. And for the machine translation, we just use a standard transformer-based approach to just like get the translation for any English text. Okay, so that is like the experimentation setup for the cascade approach. So there is not much to say. We didn't do much of the work on that side because basically we use a pre-trained model, and we use also somehow a pre-trained model from the Masakane community to do the translation part. We return it a little bit, but basically that is the idea. But for the end-to-end system, this is where something interesting happened. We use, again, a transformer-based architecture, but this transformer-based architecture was a little bit different because traditionally you have one encoder and one decoder when you want to do machine translation. But in this case, we don't want just to do translation. We want to do recognition and then translation. So basically, there's this great work by Liu and all in 2020, and they introduced this one encoder, two decoder architecture. As you can see in this picture, basically, you have the speech on the encoder part, and the output of this encoder is get distributed to two decoders. So two different decoders that share information between them. So this is where the decoders are kind of communicating, but basically one decoder is kind of responsible for recognition part, and the other decoder is responsible for the translation part. And all of this is end-to-end. So basically there is no error propagation, as to say, in this stage where like one system is depending on the other, but all of them kind of communicate internally to achieve a common task, which is automatic speech translation. So this is the architecture how it look. And the most important thing here is to look, because for some of you that are familiar with the transformer architecture, this says something to you. But the difference is on this part, what they call the interactive attention, which is basically sharing information between the recognition part and the translation part. The way this interactive attention, if you zoom a little bit into that, it's made of a self-attention and a cross-attention. So there is a self-attention on top of the translation information on this part. So you can see that the query, the key, and the value, as you know, with the standard calculation of the attention and the formula for those that are curious, this formula on this side. So basically, the novelty in this architecture is that there is those two things are sharing the same query. So the attention for the transcription and the attention from the translation are both sharing the same query. And that is really what brought the breakthrough in this direction, because basically they kind of communicate. And there is an additional thing that was used here that I will explain further in the next slide, where there was some kind of waiting scenario where the translation decoder is kind of leaving some few seconds to the recognition decoder to get the output before it can start working, just to allow a little bit of the flow happening end to end. And we experiment with different number of seconds just to see how much we need to wait before the translation decoder start to process the informations. Yes, and I know that there will be some question on this. We can get back to that later on. But basically, the result that we got was as follow. And first, I want to say this, that for this end-to-end system, we basically retrain all things from scratch. But we used a dataset, which is unfortunately not open anymore. It was open back then. I was lucky to just download it and have it on my drive, but it has been closed. It is the third speech translation dataset, which was basically like English to French, to Portuguese, and so on. So we used that one to basically train the decoder of the recognition, because you have two decoders. We have the translation decoder and the recognition decoder. So we trained the recognition decoder using the text speech translation, and we trained the translation decoder using the GW dataset. So separately, we managed to train these two decoders, pre-train them before actually we run it end to end. And given that the speech-to-text task is more difficult, as to say, often than the machine translation, we used what we call the wait K policy. So what was happening here, that's something that I said in the previous slide. So we wait for 1 second before the translation decoder pick the task and see the result. Then we wait for 2 seconds. We did that for 4 or 5 seconds to see what are the optimal time we need to wait for the model to have, higher performance. And after playing with a lot of numbers, we realized that the best number was waiting for 2 seconds. Like for K equal 2, the results were better. As to say, by result here, we mean the word error rate for this task, like for English to Lingala. And the result on the first line, you can see the pipeline approach. As you can see, there are no results on this part, because for the pipeline, we didn't use any wait K policy because it was hand-to-hand. So if you remember, serial low and machine translation model. And we had a good word error rate. Think about it, this was in 2021. Was it 21 or 20? It was like 2 years ago we did this research, and this number was really amazing to see that we managed to have for the pipeline approach. We didn't do much, but you can see that the pipeline approach gives 8.24 error rate, where the end-to-end system that we built ourselves was lower than the pipeline approach. In this case, the lower the better, as you can see from the arrow. So the end-to-end system quite performed better than the pipeline approach, which was surprising because people were expecting to be the other way around. And also we looked also at the blue score, and as well as the blue for for English, the transcription of English, and the blue for the translation of Lingala. And you can see that as we move through the wait K policy, we go to the wait of 2 seconds. Basically, we had better result. You can see there is a big shift here in the performance because we allowed basically the recognition decoder to wait a little bit before starting the translation decoder, picking up the task. And when you move a little bit to wait 3, wait 4, the result was degrading. So we decided to look at wait 2 as the best number. This was some kind of parameter tuning, just looking the right value that we can use for this experiment. Okay, so that is all about the result we obtained for this specific task. And in conclusion, basically for this work, what we did, so we presented LiSTra, which stands for Lingala Speech Translation, which is the first, at the best of our knowledge, a data set for automatic speech translation from English to Lingala. And we also have a pipeline approach and end-to-end approach to allow researchers, people like you, to just go to the code base that we open source, to just look at it, run it again for yourself, and try to see how well you can achieve something like this for your own language of interest. And the next thing is that one question that I often get after giving this presentation is people asking, this text is, as you said, it from the Bible. So what it bias, inherited bias. So how can we do with this kind of text? So of course, this text is biased because it only trained on specific domain in religious context. But this is a good proof of concept, for example, showing people that this can work with this kind of data. If we have the possibility of getting more data, we can have something better. Or if we can get some news or other publication related data to fine tune again this model, the model can be a little bit more inclusive or have a different set of vocabularies. So we are aware of how biased this experiment was, but we did it as a proof of concept just to see how good or how feasible is it to have this kind of working system that people can use. And the next thing is that in addition to the pipeline, we have the end-to-end architecture and the code. That was the most difficult part, was how can we have the 2 decoder and everything working together to achieve one task. All of that were also released to the community for experiment. Okay. So for the future work, someone can look into how to further pre-train the recognition and the translation decoder separately with different source of data, with different domain of the data, just to see how far you can push the word error rate, because this is the first experiment in Lingala, and I know there's a lot of researchers outside there, some of them in this call, to just see how you can push it further for the Lingala community. And some of the things that I've been interested on recently is that I know that a lot of people like Congolese song, people like singing Lingala song, but most of the time they don't know what is the meaning of this song. So that will be a good step forward, or a next step with this research, is how can you find a way to just tweak the architecture to have a way of having these Lingala songs being maybe printed or having a live captioning in French or in English for people that like Congolese songs. Then, if you are interested, what are the next steps? Where can you start from? So I will quickly go through this. I know that we are running out of the time, but the first step is select your pair language. What are the language that you want to work with, and having them decide which language you want to go with. I know that there is a lot of architecture nowadays. I think the community has moved in a little bit. You can see what other architecture are outside there. Maybe there are some unsupervised or multi-language setup. I'm not really much again aware of what is happening in that side, but just select your pair language and see what is available outside there. What is in the, do your literature search to see what is happening now. But from this work perspective, the next action will be basically to edit a couple of specific notebook that I shared, because for the Bible we use, Bible is for scrapping the text in English. And also we did some other work with GW website. So I released the two notebooks that will allow you, they are not 100% clean. As you can remember, I was doing my master degree, so I just did it that way. So if you have questions, you can just write some issue. I can have time to look into that. But basically, you can just look at the code, run it by yourself, change the target language, change a couple of stuff in the script, just to make sure that it will allow you to re-download the dataset by yourself and having it ready to use. The reason we use two different websites is because the Lingala Bible was not really fully present in the Bible is website, so we had to use the GW website. And the next step on this direction will be to use the web mouse. So instead of just using the web interface, we give the possibility of having a notebooks, which is using the API of webmouse. When you give it a speech, it will, truncate the text and allow you to do experimentation in that direction. Okay, and then the last thing is, after having this data ready, the next thing is basically just using the models, the end-to-end model. And on this same place, you will see this code is basically hosted in Fukosi lab. So Dr. Fukosi was one of my supervisors, together with Dr. Herman Kemper from Stellenbosch University. So this work is hosted in their GitHub, but it open, so you can just go there and look at the end-to-end code, modify it, or do experiment as you want. So those are like the next step that I can think of, and I'm happy to discuss more if some other people have other thoughts. Yeah, so that basically everything that I had prepared for all of you today. If you want to learn more about me, this is my website on the screen. And you can also follow me on Twitter, Salomon Kabongo, and we can discuss in that way. Thank you very much, and I'm happy to take questions if there are any.
Thank you so much, Mr. Salomon. Let me allow people to unmute themselves and ask questions if they do.
Hello.
Hi.
Hello.
Hi, we can hear you, Abdul.
Yeah. Okay. Thank you very much, Mr. Solomon, as well. I think that was a nice presentation. Yeah, by all standards. My interest is in terms of the data set creation. I joined a little bit in between the presentation, but then I'm most interested in the data set presentation because we are also having to do some work around that area. Then we are looking at doing some local translation within the legal framework, and then we are struggling with the data set. As is very keen with low resource languages. So I'm much interested to know how you went about the data set creation between both the speech language and also the text. Yeah, if there's if you can throw more light on that.
Sure.
Thank you.
Happy to do that, and thank you. I can go some slide back just to show you, to comment a little bit on the data creation. And I can say for sure that this is a challenge overall to construct data set for low resource languages. And that the main reason that motivated that to go for the Bible. As you know, there have been a lot of missionary in the African continent, and they did already a great work of translating the Bible in different languages. So that is one signal that we know for sure that we can have data that are aligned in this case. And for our user case, all the data set is made of the reading of the Bible, a transcription as well as the translation. So we use a website to just download the wave, like the speech of Genesis chapter 1. In this case, you can see it on the left side. This is a file that contains the reading only of one verse of the Bible. And we went to the same website because it is a reading of the Bible to just have the text that we know that this is Genesis chapter 1, verse 1. And we know that the speech also is saying the same thing. We went to another version of the Bible to get then the Lingala version of that same verse. So this is how we went about constructing our own data. I will say, Abdul, that this is the easiest way because you know that the Bible is aligned. We had some challenge where some English version, a book of the Bible end at verse 20, but the Lingala version said that it ended at verse 18 because some of the verses are kind of put together. So those are the things that we did in pre-processing, making sure that it is aligned, using some user, validation and stuff like that. But if you want to go outside of the Bible, this is where it gets more challenging, because even if you go for news website, in this case, we have three things that need to be aligned: the speech, the transcription, and the translation. So like from our point of view, it was difficult to get anything that is outside there to be aligned in this setup exactly as we want it to be. I don't know if that brings some light for your question.
Okay, that's very clear. Thank you very much.
Sure.
Thank you.
I have a follow-up question to that. So, as I understand, one major issue is alignment. Are there some works on either automatic alignment or trying maybe some kind of speech translation that doesn't depend so much on alignment? Because it seems like this alignment issue, especially for African low resource languages, might be a major challenge for people to continue in this work, for example. What do you think about that?
Yeah, I think that's a great question, basically, because it's expensive, if I have to say it that way, to even if someone need to invest in constructing this kind of alignment, it will cost a lot of money to have people aligning speech, text, and translation. So the setup is not great. When I was still pushing research in that direction, I had a lot of people trying to eliminate the need of having the tree aligned, having some way of just unsupervised text and speech, and run a code on that will some kind of align text or learn some kind of alignment automatically. So now I've heard of work like that. I didn't follow up on that, but there is definitely people thinking in that direction and still thinking on improving the setup in that way. So I will not answer your question fully. As I said, this work was done 2 years ago, and currently my PhD is not close to this one. It's something else. But it will be worth it to just look at the literature to see what changed. What are people using currently? So I'm also curious because Google recently put this auto speech translation for Lingala. They have been doing it for other languages. So I don't know what they use behind the scene. Maybe some people can know more about that. Maybe they found a way to go around avoiding the tree alignment or not. So that's something that one need to do a research to find out. I'm afraid that I will not have an answer for that question exactly. Yeah.
Thank you very much. Do we have any more questions from the audience?
Yes. First of all, thank you very much for this illuminating presentation. Learned a lot. I have an interest in NLP and kind of have been looking for a way to jump in and get started. And I appreciate your slide about how we can go ahead and get started. My comment was my question was, I think based on what you presented, if we go to your GitHub link, we can actually recreate everything you've done with our own pairing of languages. Is that correct?
Yes, that is correct. But it depends on the pair of language, I will say, because if you remember for the pre-train, if you want to do the end-to-end system, for the pre-train of the speech part, I use the TED speech data set that is not available anymore. If someone is interested, we can find a way of dealing with that part. But basically, if you go for a pair of language where you don't have a pre-trained model available outside there, it will be difficult. The script will help you to run the system if all the prerequisite is ready. So basically, if you have pre-trained the decoders, the two decoders, like if let's say you take French and Yoruba, for example, there is no this TED data set that I used. I'm not sure if they have that pair language. So you may have a couple of issues in that direction, but if you have a pair language, just look at what is available to pre-train, because without pre-training any of these decoders, you are going to have a hard time get a better result. Because it's very difficult with only 21. I think I had only around less than 100 hours of readings, and any speech recognition below 100 hours is difficult to get good word error rate, because if you fail getting good word error rate, like getting the good transcription, even the decoder for translation is going to fail dramatically. So that's the issue.
Thank you very much for that. Are you able to put the link to your GitHub, maybe in the chat, or how?
Sure, I can do that. Yeah.
Thank you.
Thank you so much. I have a question about deployment. So this is the first. I'm guessing you're one of the first people that attempted this for Lingala. My question was kind of, looking at the trend for Lingala, and in terms of research and the data sets, the available data sets and pre-trained models. These are the components that are needed. How long do you envision before we could have automatic speech translation systems that can be deployed and used in real life for Lingala? But then you mentioned the Google thing, and that seems like it's already quite soon. But I guess I'm more interested not in the big tech, but more in maybe startups or smaller companies in Africa implementing this.
Yeah, I think that's a good question, and I'm actually making an open call here. If anyone is interested into for example, these lyrics things that I talk about for Lingala songs. So I know that definitely in this call there should be people that like Congolese songs, and one of the things that they struggle, they have to find a Congolese to translate for them. What is this guy saying? I like the melody, but I don't get anything. So I've been thinking on how can we set up this as a task. And there are some data sets that are available for doing these kind of things. And I'm happy to partner with anyone who has some time, because I'm currently kind of busy with other stuff, but we can partner with people. I think if there is people that are interested, it's easy to have something working and deployed, maybe a demo version of it, because as you know, when we deploy the first version, it will not be perfect, but at least a working prototype can be doable in 1 hour or in 1 year or two max, to have something that people can rely on and work on that. For example, some of the work we did with Masakane, for example, was in this translation.masakane, and there is also work from speech.masakane.io for people that are interested. And we want also to extend these things further. So one of the things, if you are part of Masakane, we are looking also in how can we have this, deploy something that can do speech to text translation. And if you're interested in Lingala, or even if you are 2 people, 3 people interested in any specific other language, I'm happy to assist with my little experience in this way, to just point you to the right resources, and sometime maybe think about the issue you are facing, so that we can make sure that we have these models, deploy it inside our servers and our Masakane services, so that the community can start playing with it more and more. I will put the link to the Masakane services for those that have not. Okay, thank you, Chris, for putting the link already. Yep. So that's what I can say.
Thank you very much. Do you have any questions from the audience before I ask my last question? Okay, I think I'll go ahead and ask my last question. I'm just curious, in the work you did. So I see data sets were needed. I see pre-trained models were needed. I also see that having some knowledge of some technical knowledge is needed to kind of navigate the notebooks. Among all these components and things needed, what was the most difficult to get your hands on? So I'm just trying to understand what's one of the most difficult components when it comes to doing something like automatic speech translation for an African language. What's really what's lacking and what needs to be there so much?
Yeah, that's a good question. And One of the things that I struggled a lot, I spent a lot of time working on was the data set, like getting the data set right. That was like the biggest problem because most of the time, the code base, you can reuse people code base. There is a lot of people in the community that open source the code, like the code that I shared with you, you will see in the GitHub. That code is basically constructed from code of people built on top of a lot of tutorial codes. And that's pretty much the scenario every time. People will be building upon each other work. But how do we get the data set right? That was the biggest challenge. Because think about it, we did some web scraping. So this is something that a tool is going automatically to a website, extracting content. We need to make sure that there are no confusion, because if the data set is confused already, you cannot expect to get something that makes sense. So we had to go through the data set. And the advantage that I speak Lingala, I speak English, I speak French. So basically, I could say that this translation makes sense, or there are more words in Lingala that are not present in the speech. So I had to listen to the speech, I had to read the transcription in Lingala, in English, and see if that is exactly what the Lingala version is saying. So that was like the most difficult part, and I was alone in this project, basically the one doing the work by itself. And it was difficult to go through almost these 60 hours. I didn't go through everything, but I randomly picked a couple of hours just to make sure that what my web scraping script is doing is correct. So from my point of view, that will be the more difficult challenge, getting the data set right. And when you get the data set right, then the later part is a little bit less challenging. Of course, there are issues with how you make this decoder communicate, how do you make sure that you don't get CUDA out of memory. Those are technical stuff that Stack Overflow can easily help with.
I see. So the data set is gold. It's the key, right? And when you say getting it right, you also mean, making sure it's clean, and in the right format for the model to learn from.
Exactly. Yeah.
I see. Okay, that's wonderful.
Sorry, I do have a question. In fact, I do have two questions. The first one, because I don't know, is Lingala already transcripted? And the second one is, how did you tackle transcription errors for translation?
I didn't quite get the first question. Can you please repeat the first question?
My first question was was the Lingala already transcribed, or you did the work? Yeah. Thank you.
Yeah, thank you. So first, for this work, we were going into one direction. We moved from speech in English to the translation in Lingala. And that was a choice made by design, because we know for sure that there is a lot of automatic speech recognition work done in English. Because the more difficult part is as you say, the recognition error, the speech recognition error. That's the more difficult part. And because we use, for the pipeline approach, we use the Cirilo model, which was the state of the art back then. So it has less error rate it is written already in a lot of data, some of the open source data in speech. And what we use, just this model, we pass it our own data set. And we see the error rate on how it's transcribed. That, as you could see from my result, we had something around 8 point something word error rate. And that was the best we could get with the pipeline approach. But when we went for the end-to-end approach, of course, there are still errors on the transcription part. So we just wanted to optimize the system end-to-end for the speech translation task overall. So we had some small error on the transcription part. As you could see from the result, we had, after weight k equal 2, we had 7 point something of word error rate, which is great already, because one of the things that you need to keep in mind, Sire, is that all of this is an approximation. So we are trying to approximate some kind of distribution. So the result will not be 100% correct. but from our evaluation, at least, we could pretty much mitigate and have transcription in Lingala pretty much correct, so someone can get the context of what someone is saying in the audio just by looking on how the output of our system is. So we didn't really go into a detailed study on how to handle the issue with where our system is failing. No, our main purpose was just making sure that we have something that is working first with a good word error rate. And next step, maybe if you are interested, is going into where our model failing. Why is it failing? Is it because those words are not Bible related or something like that? So yeah, so that's what I can say for that.
Thank you.
Sure.
We have a message, question from Sam L.
Yes, I just wanted to know, so if we really wanted to get involved in the community on the Masakane website, is there like a chat group, a Slack where questions can be answered in real time, or how would that work? Like if we wanted to reach out to someone to unblock ourselves on something we were trying or wanted advice, wanted someone to point us in the right direction to data sets or things like that. Is there a kind of real-time chat, Discord, Slack group for that?
Yes, there is a Masakane. I don't know, Chris, if you don't mind. I don't know if you have the link to how to join Masakane. It should be on the website, themasakane.io. So basically, we have a Slack channel where we have also a specific channel for speech, for machine translation in the journal, and people are very responsive. So that will be the right place to join. And thank Chris for the link. So you can just go to that link, join the Slack, and go to the appropriate section of thing that you are interested, and you will get people answering in less than 24 hours often. Yeah.
Thank you.
Sure.
Okay. Any last?
Hello.
Okay. Yeah.
Hello, Salomon. This is just like something to pick up from your experience in terms of this word because of similar experiences. In terms of trying to build your vocabularies, I guess in terms of the tokenization area and building your vocabularies, how well did your understanding of the Lingala language played in that area so that you were trying to come up with if there's any advice you can give around that thing?
Yeah. Yeah, that is a funny question, because I'm thinking about what was happening when I was building this system, and it make me laugh because for people that are familiar with tokenization, so basically you need to start to teach the system how it should process, because the thing is that we need to encode these text things in numerical value, so that, because computers work with numbers, just to make sure for people that are not into technical things in NLP. So you need to have a kind of understanding of what Lingala is. And I think that played a big role. I didn't feel it at the time, but now that I think about it, it really kind of, you have some kind of intuition on how to set your regular expression. I was setting a couple of regular expression and stuff just to make sure that the way I'm cleaning, because if you do the standard English cleaning in Lingala, you are going to lose a lot of words, because some of the words will be seen as, alphanumeric character or something that need to be removed from the text before doing the actual task. But actually, those are the things that are important to get the actual language. So if you want to do something, thank Abdul for asking this question. This is an important thing that I somehow forgot to say. You need to make sure that you look at your tokenizer and the rules and all the concepts that are put there make sense for your own language, because there are language with characters that doesn't seem right for the English language or for the standard tokenizer. So what I did for my case, I used the standard code for tokenization, but I removed some rules, I removed some code to make sure that I can still account some strange characters to say, because those characters make sense for my language. Yeah, I don't know if I answer your question.
Oh, that's very impressive. Thank you very much, as well. Thank you. Really appreciate.
Yeah.
As a follow-up to Abdul's question, what about evaluation? So did knowledge of the language help you to evaluate the performance of the model better, or it didn't really have much impact?
It did it did have all the impact because like I was the only one evaluating that. And one of the things that happened, for example, is that when you cut with these web mouse tools, um, the speech of a verse, sometimes it goes, what happened was actually when I have the speech for verse 1, the transcription actually matched the speech, but the Lingala translation on the data itself basically had additional Lingala words that are not contained in the speech or the transcription. And that was on the cleaning of the data set. But when I was doing the evaluation, I noticed also like there were some repetitive words or some words that were out of the place in the Lingala part. And that was something that you can only notice because you speak the language, not just because you count the number of characters. For example, if you look at the slide I show you like a sentence of length 3 in English, the translation in Lingala is length 10. So you can't just look at the visual aspect of the language that, okay, this is making sense or this doesn't make sense. You have to read and understand it in order to know if your system is giving a right result. So I think from my experience and the experiment I did, knowing a language played a very big role because I knew when to say that the system got it right and when to say that the system got it wrong, not just by looking the word error rate or the blue score. I rely on that for the paper publication, but for my own experiment, if I have to release system to Congolese people, you're not going to tell them that forget about why the system is giving us the output, believe my word error rate. No, they want to see if the system is actually translating what the person is saying in the speech. So I think that was very important for me. And of course, the system didn't do everything right, but I could see where the system is failing because I knew the language, both language.
That's wonderful. Thank you, Jonathan.
Yeah, thanks a lot. I'm happy to be here. Apologies, I may have joined in when actually I'd progressed for some time. But maybe just in case it has already been mentioned, someone could refer me to somewhere on this. But I'm kind of interested to know like the quantity of your data sets, what you use in terms of the size. Because as you know, when normally even working with Masakano, we're always faced with these issues of what could be the minimum size of data sets that could give us something that can be usable. And maybe from your experiments, you did try out to use to kind of vary the size of the data sets as you try to do your experiments. It's something that I'll be interested in knowing. And also maybe the other one could be more about the resources in terms of GPU and things like that.
Yeah,
thank you.
Great, Jonathan. And thank you. We are happy to have you also on the call. So I'm sharing my screen quickly just to show you the screen on the data set itself. So for the English part, so for English, we had the speech and the text. The text was around 23,000 line examples, as it commonly say. And every example for this data set, the average length of one example was around 23, words. And this is basically the start. You can see it in because this work was published. We published it Black in AI. I think we submitted in one workshop. And you can see the data set there. So if you just type LiSTra on archive, probably you will see that. I don't know if I already uploaded it on archive. I have to check that. But on the speech part, we had 61 hours of reading. So that's like the Bible from Genesis to Apocalypse. So it's not fully 61. We left out some other things that were kind of not aligning correctly. And for every one example, we had an average of 9 seconds, of the length of the speech in our data set. So this is basically everything around like the data set statistic. You can look into that. Regarding the resources we use, as I said, when I was doing this work, I was affiliated with at the University of Pretoria under Dr. Vukosi Barivate. So we were using the GPU from his lab. So I used one V100 GPU, and at a certain time I used also two of the V100, but basically that's what I used for the resources. It cost a little bit, so but yeah, it was under the lab of Vukosi. Yeah.
Yeah, thanks a lot. Maybe just a follow-up question again. I normally train speech recognition models in Uganda for quite a number of low-resource languages. But sometimes, maybe depending on the size of the data set, I end up, even when I have resources, I end up maybe training for longer hours, even 24 hours, which sometimes seems to be costly. So in this case, did you ever train for more than 24 hours? And the reason why I'm actually mentioning this is I just want to kind of get a picture of, in terms of resources, how long this could take me.
Yeah, I think that was costly, because I remember that I ran it for more than 2 days, if I remember correctly. Like the end-to-end system. I ran it for first, as I said, because I started it from scratch. The thing with the end-to-end system is that I could not use the pre-trained, I could not use a pre-trained model to give to the decoders. Because if you have to use to fine-tune on a pre-trained model, it should be a pre-trained that align with your task. So I didn't see anything that was aligning with my setup task. So I used this third speech dataset, which was like it had 200 hours. It was it was more than 100,000 hours. So I retrained. It was like Libre speech, but Libre speech is kind of bigger. But I had this third speech, which was like set up for speech to text translation. I pre-trained that for like more than 2 days. And I remember, if I remember correctly, I think because he asked me like, are you still running something? Because like it was costing a lot. I don't know the number, I have to check that. But definitely I run it for more than 1 day, the pre-trained part. And then I run it for a couple of hours, then for the end-to-end with my own data set. So I did like 2 things with the end-to-end model. I pre-train it on some bigger data set just for the decoder to learn what it means to do recognition and what it means to do translation. Then I put it my 61 hours and train it a little bit, kind of fine-tune it and see the result with that. Yeah.
Sounds very great. Yeah, Jonathan says thank you in the chat. Do we have
Sure.
any more questions? We have 15 minutes. Okay, I'm sure it was a very, very exciting talk. Lots of questions. If you have more questions, you can reach out to Salomon. Salomon, you can put your contact details in the chat, and also in the YouTube video, his contact details will be there. So yeah, don't worry if you miss it now. So with this, I will come to the end of this talk. And I say thank you very much, everyone, for joining us in this wonderful talk. Thank you so much, Mr. Solomon, for your wonderful talk. It was truly inspiring, and truly very, very inspiring on how people can do efforts, no matter how little or how big, for Lingala. And the work on automatic speech translation is a very useful thing, because like you gave the thing with the lyrics, that's just one way of its application. It can be applied in many things in life, and speech translation is not something that is very popular, especially among African low resource languages. So thank you so much for showing us how to do it and showing us why to do it, why it's important, and how we all can do it. And also the other links, notebooks you put are very useful. We'll try to put them in the YouTube description so people could also use it and work on that. Thank you so much once again, everyone. Hope to see you in our next Lanfrica Talks, and have a great day. Bye.
Thank you. Thank Chris. Bye.